Ever wonder what makes an airbag explode into action in a crash? It's not just one simple switch. It's a complex, split-second decision made by a sophisticated computer system in your car. Let's break down the code and mechanics behind this life-saving technology. Your car is packed with sensors. The most important ones for airbags are the accelerometers. These tiny devices measure how quickly your car is slowing down or Imagine you're driving along, and suddenly you hit something. The car's velocity changes drastically. The accelerometers detect this sudden, violent change and send a signal to the car's brain. The airbag control unit, or But how does the AC, if it has a real crash or just see slamming on the brakes or hitting a big pothole? This is where the smarts come in. The ACU is programmed with complex algorithms. It's constantly analyzing the data from the looking for a specific deceleration signature. A pattern of slowing down that S characteristic of a serious collision. This isn't just about how hard you stop. It's about how quickly the deceleration happens. A panic brake is a strong deceleration, but it's spread out over a fraction of a second. A crash is almost instantaneous. The ACU is trained to tell the difference. Think of it like a bouncer at a club. The bouncer isn't just looking at how you're dressed. They're looking at your ID, your behavior, everything, to decide if you get in. The ACU is the bouncer for the airbag system. It's not just looking at one piece of data. Modern cars often have multiple sensors, not just at the front, but also on the sides. To detect different types of impacts, there might be pressure sensors in the doors for side impacts, and even gyroscopic sensors to detect a rollover. The ACU cross-references all this information. Is the front accelerometer screaming major impact? Do the side sensors agree? What about the wheel speed sensors? Did the wheels stop turning suddenly? By combining all these data points, the ACU builds a complete picture of the event in milliseconds. It compares this picture to thousands of crash scenarios that engineers have programmed into its memory. These scenarios are developed from countless real-world crash tests. If the data matches the profile of a severe crash one, where the occupants are likely to hit the steering wheel or dashboard, the ACU makes the call. It sends an electrical signal to the airbag's inflator module. This isn't a simple mechanical trigger. It's a precisely timed command. The signal ignites a chemical propellant, usually sodium azide. This reaction produces a massive amount of harmless nitrogen gas, instantly inflating the airbag at speeds of up to 200 miles per hour. The whole process, from impact to full inflation, takes about 20 to 50 milliseconds. That's faster than the blink of an eye, and the system is even smarter than that. It also decides which airbags to deploy. A frontal collision might only deploy the front airbags. A side impact might deploy the side curtain airbags. Advanced systems can even determine the severity of the crash and deploy the airbags with different levels of force, lower force for a less severe crash to minimize injury from the airbag itself. They also take into account whether a passenger is present and if they're wearing their seatbelt, using seat occupancy and seatbelt buckle sensors. If the passenger seat is empty, why waste an airbag? So, the next time you get in your car, remember the silent guardian working behind the scenes. It's not just a bag of air, it's a network of sensors, a powerful computer, an incredibly sophisticated code, all working together in a fraction of a second to make a life or death decision. It's a testament to how far automotive safety engineering has come. Thanks for watching. If you found this dive into automotive tech interesting, hit that like button and subscribe for more deep dives. See you in the next one.